Hi everyone, this is Professor H. Rahman from Agricultural and Food Engineering Department, IIT Kharagpur. I welcome you all to this NPTEL online course on traction engineering. This is the lecture 4 where I will try to cover different tractive performance parameters. So, concept is sleep, motion resistance ratio, net traction ratio, gross traction ratio, tractive efficiency, power delivery efficiency. These are the parameters which are associated with a tractor or a truck during operation in the field. So, if you want to evaluate the performance, then these are the parameters to be studied. Under traction parameters, there will be travel reduction ratio, which is otherwise called sleep, the net traction ratio, which is otherwise called coefficient of traction, then tractive efficiency, gross traction ratio, which is otherwise called coefficient of gross traction, then motion resistance ratio, which is called coefficient of rolling resistance. Now, I will discuss in detail how we define sleep, how we define the other parameters in order. Now, sleep, as you know, everyone says the wheel sleeps. What exactly is happening is the wheel is not covering the same distance as it is supposed to cover. So, if the original velocity is Vt, that means original means there is no load applied to the wheel, simply we roll the wheel. So, that if you denote it as Vt, and when you apply a load because of the interaction with the soil, soil and tire, there will be slippage of wheel. So, wheel will not cover the same distance. So, it will cover lesser distance. So, speed is reduced. So, that we denote as Va. So, that difference is expressed with respect to Vt and that is expressed as percentage. Now, this is very simple. Simply I have written sleep is equal to Vt minus Va divided by Vt into 100. Actually, what happens if we are moving a tractor or if you are moving a wheel, single wheel at angular speed of omega, omega is the angular speed and V is the forward is the angular speed and V is the actual speed. So, in 1 second, so the distance covered in 1 second will be 2 pi by omega into V. So, this is the basic 2 pi by omega. So, when there is load, when there is no load, so these two will be different. Now, sleep I can define as in the other way 2 pi V by omega with load, without load minus 2 pi V by omega with load divided by 2 pi by omega into V without load. So, 2 pi if I cancel out, so V by omega without load and V by omega with load, then V by omega without load. So, when angular speed remains same, then this is same as sleep, which I defined earlier. So, in this equation, the main important thing is we should know that we should confirm that omega is remaining constant. So that is the important thing. And the slip generally we consider at zero condition. Zero condition means zero condition refers to self-propelled condition. So that becomes our zero slip. Okay, and slip is occurring because of tire flexing, because of improper interaction between the tire and the soil, because of the tire sticking, because of the shearing within the soil. So these are the factors which will try to influence slip. More the pull, more will the slip. The best concept is without slipping, a tractor cannot develop tractive force. So slip has to be there. Now question arises, how much slip? So that depends again on the soil condition, again on the type of tire. So roughly we say within 20% is the allowable slip, where you can get maximum tractive effort. Next is, we will discuss the other performance parameters, motion resistance ratio, or in other words we call it coefficient of rolling resistance. So if you look at this figure, is a pneumatic tire operating on a soft soil, this one, sorry. And this is the pneumatic tire which is operated on a hard surface. What is the difference if you look at the tire is deflected? In a soft soil, tire has sunk, there is deflection as well as the tire has sunk. That means it has entered into the soil. Whereas in case of hard soil, the tire is only deflected. So the rolling resistance in both the cases are not same. In a soft soil, since tire has sunk into the soil, so rolling resistance for the same operating condition will be little higher. Whereas in case of a hard surface, since tire has not sunk, only it has been flattened, so the rolling resistance will be little lesser than the rolling resistance which is experienced in soft soil. So from this discussion, what you can conclude is, yes, rolling resistance, which is nothing but the sum of the forces acting opposite to the direction of motion. If you look at this figure, you can see the R arrow has been indicated opposite to the direction of travel. This is the direction of travel and the R has been indicated opposite to that. So this R depends on certain factors like what will be the tire flexing, how much is the sinkage, how much is the bulldozing, and how much soil is adhered to the tractor tire. So we define rolling resistance divided by W as coefficient of rolling resistance. That means we measure rolling resistance, then divide by W. W is the weight coming on the wheel. Coefficient of that becomes coefficient of rolling resistance. Now the other parameter is net traction ratio, or in other words we call it coefficient of traction, which is nothing but the pull which is developed divided by weight. But weight here I have indicated as WD. WD means dynamic weight. The tractor which I have indicated on the right side, and this is a single wheel. In case of a single wheel, we can take WD as equal to W itself. But in case of a tractor, we cannot take W, which is the weight of the tractor, and the denominator. The reason is, if it is a two-wheel drive tractor, there will be distribution of weight to the front axle, there will be weight distributed to the rear axle. So, if total weight is W, then we can divide it so W is divided into front axle plus rear axle, capital R. So, but in case of a single wheel, it is the same weight, whereas in case of a two-wheel drive tractor, only the rear wheels are powered wheels. So, we are not concerned about the front wheel. The net traction ratio will be related to the rear wheels. Okay. So, in rear wheels, what happens when we try to pull certain implement, there will be weight transfer from the front wheel to the rear wheel. There will be weight transfer from the implement side to the rear wheel. So, that means in a static condition, when there is no implement attached, then if the weight distribution, that means the weight coming in the rear axle is WR, in the dynamic condition, the WR doesn't remain as WR. Some additional weight is coming from the front wheel side, coming from the implement side. So, the dynamic weight on the rear axle will be equal to WR plus some weight transfer, which I have denoted as WTR. So, while calculating the coefficient of traction, we have to divide the pool which is developed with this dynamic weight, not the static weight which I have written as WR. So, that is the difference for net traction ratio in case of a single wheel and in case of a tractor. Now, coming to gross traction ratio. This is the total tractive force or thrust which is developed at the interface of soil and wheel divided by the weight. It is in the same way. Weight means if it is a single wheel, then we simply divide it by, if T is the thrust developed, T is the thrust developed, this is T is the thrust which is developed, then thrust divided by weight. If it is a single wheel, whatever weight is coming on the wheel, I can directly take as W. But again, if you look at the tractor rear wheel, then when it is used for pulling an implement, during that time there will be weight transfer from the front, there will be weight transfer from the implement side to the rear axle. So, what will happen? The initial distribution, which is denoted as WF and WR, that will no longer remain as WF and WR. So, WF will be reduced, that is the weight coming on the front axle will be reduced, weight coming on the rear axle will be increased because of the weight transfer from the implement side, because of the weight transfer from the front axle. So, the new weight, which I denoted as WDR, better you can write WDR. So, T, so for a tractor, we can define the coefficient of gross traction GTR as T by WDR. Okay, and we know that thrust is equal to your pull versus and the rolling resistance. So, that means pull plus rolling resistance will be equal to thrust. Now, if I divide W throughout the equation, T by W, P by W and R by W. This W is the dynamic weight if we are talking about tractor. So, then this ratio is called coefficient of gross traction. This is CGTR which is equal to P by WD. This is nothing but COT, coefficient of traction or coefficient of net traction. Then R by WD, which is nothing but coefficient of rolling resistance. So in other words, I can say GTR will be equal to coefficient of net traction NTR, or we can say COT plus coefficient of rolling resistance. So here one thing we have to take into consideration, that W should be dynamic weight, it is not the static weight. Whereas in case of a single wheel, you can do in the same way, but here it will be simply the W. There is no weight transfer in case of a single wheel. So we can take this as T by W equal to P by W plus R by W. This W is not the dynamic weight. Here the dynamic and static weight, they remain same. Next is tractive efficiency. This is a very important parameter while evaluating the performance of a tire or a tractor. So as the name implies, tractive efficiency. So efficiency means there will be some output, there will be some input. So output by input is your efficiency. Now what is tractive efficiency? It is the drawbar power divided by the axial power, and it is expressed in percentage. So in other words, you can say the tractive efficiency indicates how much of the axial power is being utilized as drawbar power. So what is drawbar power? If somebody is interested to find out what is drawbar power, is the power available at the drawbar. So power available at the drawbar will be equal to power available at the drawbar this will be equal to P into VA. VA is the actual velocity. So this becomes your power available at the drawbar. Now what is axial power? Input axial torque, if is denoted as T into omega. T into omega. Omega is the angular speed. So I can write this expression tractive efficiency as P into VA by T into omega. So this input torque I can write as thrust into rolling radius. Now if I substitute here, so P into VA divided by T is nothing but your thrust into rolling radius R, suppose I denote it as R into omega. See, this omega R is nothing but your theoretical speed. If omega is the angular speed, multiply the rolling radius, that will give you angular speed. So P into VA by thrust into VT, theoretical speed. So I can write in other words P by thrust into 1 minus slip, because earlier we have defined slip is equal to 1 minus VA by VT, right? So now I am substituting in this equation, so that gives you P by thrust, P by W into 1 minus S. Further, if I want to express in terms of coefficient of traction or in terms of coefficient of gross traction, then what I can do is I just simply divide P by W with thrust by W. This W is dynamic weight in case of tractor. In case of single wheel, it is the same weight. Okay, so into 1 minus S. So this P by W we have already defined as coefficient of traction, which is COT. Then thrust by W, which we have defined as coefficient of gross traction, CGT into 1 minus S. So, tractive efficiency is the ratio of COT by CGT into 1 minus S. That means it takes care of pull, it takes care of the thrust, it takes care of the slip which is associated while developing thrust. So, this is a composite parameter you can call, which takes into account the different other parameters which are associated. Next is one more performance parameter I am going to define, which is called power delivery efficiency. It is again efficiency. So, that means output by input, but here I will take the output as drawbar power, but input will be no more limited to axle, it will be extended to engine. Power delivery efficiency, which is defined as the ratio of drawbar power to engine power. Now, power delivery efficiency, drawbar power by engine power. So, I just multiply in the numerator and denominator axle power by axle power. So, if I take drawbar power by axle power and axle power by engine power. So, the first ratio drawbar power by axle power is nothing but your tractive efficiency, and the axle power engine power will take care of the transmission efficiency. So, it is a product of two efficiencies. Out of this engine power, how much power is converted to drawbar power, that can be determined by utilizing this parameter. So, the tractive efficiency is a component of this power delivery efficiency, whereas power delivery efficiency gives you the overall efficiency. If engine power is say X, out of that X, how much power is converted to drawbar power. So, that is the way by which you can calculate power delivery efficiency. The details of variation of this power delivery efficiency, tractive efficiency, and coefficient of traction, coefficient of gross traction, and coefficient of rolling resistance, variation of these parameters with slip we will be discussing in the coming lecture. So, in brief, what I can say, we have discussed different performance parameters which are associated in evaluating the performance of a single wheel or in a tractor. So, if you are utilizing these parameters to evaluate for tractor, then we have to be very careful in the sense we have to always go for taking the dynamic weight. If you by mistake take the original weight, that means without weight transfer, then all your calculations will be wrongly interpreted. Okay. So, the two differences should take into consideration. One is how much weight is transferred, and that should be reflected in your coefficient of traction or coefficient of gross traction or coefficient of rolling resistance. So, in brief, this lecture I attempted to describe the different tractive performance parameters which are useful in evaluating the performance of a tractor. Then these are the books which you can refer, where you can get some more information how to calculate those things, and that will give you a better idea about this tractive performance parameters. Thank you.